Welcome back. Today I want to take a look at another way of finding the vertex. This method is probably the most commonly used method to quickly find the vertex, especially when the equation is given in standard form. But I would like to take some time today to show you where it comes from. So let's start by looking at a quadratic function here. I haven't given you the actual function, but I've indicated that it has x-intercepts at 4, 0 and at -2, 0. I've dotted in the axis of symmetry, which again should be halfway between the two sides of the parabola that I've sketched. Now notice that that axis of symmetry always goes through the vertex. And if these two sides are supposed to be the same on both sides, then these 2 points are equidistant from the axis of symmetry. Now remember, one way that we can find x-intercepts is by using the quadratic formula. And one of our solutions would be given as the opposite of b plus the square root of b squared minus 4ac all over 2a. Our other solution would be given by the opposite of b minus the square root of b squared minus 4ac all over 2a. So if I want to find the value that's halfway between these 2 points, and again visibly we can see that on the graph, what I can do is I can add these two values together because they represent the 4 and the -2. So if I add them together, it's really not going to be as ugly as it may look at the moment. Notice that I have a plus b squared minus 4ac under the radical and a minus b squared minus 4ac under the radical. So these actually cancel each other out. And what we're left with here then is the opposite of 2b over 2a. Well, that simplifies down to the opposite of b over a. This value actually gives me the distance between these 2 points. So if you think about this representing your 4 and this representing your -2, if I add that together, 4 plus -2 would give me 2. But to find the midpoint between those two, I actually would need to take half of that value. And so what we end up with then is the opposite of b over 2a. So again, if I took my 4 plus my -2, I end up with a 2, and if I take 1/2 of that, I end up with 1. Well, notice that appears to be where my axis of symmetry goes through, and it appears to be the x-coordinate of my vertex. So this little formula here, which some of you are familiar with, actually represents the x-coordinate of the vertex. And it looks similar to the quadratic formula because it actually comes from the quadratic formula. So now remember, this is only going to give me the x-coordinate of the vertex. So if I want to find that, the x-coordinate is the opposite of b over 2a. But how do I find the y-coordinate? Well, to find the y-coordinate, I simply need to evaluate the function at the opposite of b over 2a, or substitute that value back in. So my y-coordinate ends up being f of the opposite of b over 2a. So now let's take a look at the function that I actually did graph here. What I graphed was f of x is equal to x squared minus 2x minus 8. So let's see if we can use our little formula here to find the vertex. So again, the x-coordinate is going to be represented by the opposite of b over 2a. Well, my b value is -2, so that becomes the opposite of -2 over 2, and my a value is 1. So this becomes the opposite of negative 2, which is 2, over 2, which is 1. Notice we get the same value that we did when we just looked at the x-intercepts up here. But remember, that's only our x-coordinate. So now let's substitute it in to find y. To find y, we substitute it back into the function. And so we end up with 1 squared minus 2 times 1 minus 8. When we evaluate that, that's a 1 minus a 2 minus an 8, which ends up giving me negative 9. So my vertex ends up being here 1, negative 9. And we could now fill that in on the graph. Now notice I originally did not scale my y-axis, and I did that on purpose because I didn't want you to guess at where that vertex is actually at. But now I could place that on here. I know that it's at 1 and at negative 9. This value right here on the y-axis would need to be negative 9. Let's take a moment to look at the two functions that we found the vertex for in the previous two lessons, using completing the square to rewrite the functions. If we were to go back and look at them, the first one was f of x is equal to x squared minus 4x minus 5. If I use this method to find the vertex, notice x would equal the opposite of b, which in this case is going to end up being positive 4, over 2 times 1, which is 2. So 4 over 2 is equal to 2. There's my x-coordinate. To find my y-coordinate, I simply evaluate f of 2. So now I end up with 2 squared minus 4 times 2 minus 5. So that gives me 4 minus 8 minus 5, which ends up giving me a negative 9. So again here, I have an x value and a y value, so my vertex is at 2, negative 9. If you look back in your notes, that's what we came up with when we rewrote that equation. The other one we looked at was f of x is equal to 2x squared plus 2x plus 5. Again, if I look at x as the opposite of b over 2a, that's going to be a negative 2 over 2 times 2. And so on this one, we end up with negative 2 over 4, or negative 1/2 for our x value. If we plug it in to find our y value, remember we're going to evaluate f of negative 1/2, and what we're going to end up getting is 2 times negative 1/2 squared plus 2 times negative 1/2 plus 5. And again, if you don't want to use or figure this out by hand because of the fractions, use your calculator. And you should end up coming up with 9/2, which if you look back in your notes, that is the value we had for the y-coordinate of the vertex. So my vertex for this one ends up being negative 1/2 and positive 9/2. Now we've taken a look at a number of different parts of a quadratic that we want to be able to find when we're wanting to sketch the graph of a quadratic. So I want to take a moment to just summarize any of the things that I might ask you in terms of graphing. So let's look at a summary. For any quadratic function, you should be able to determine the following. Number 1, you should be able to find the vertex. Now we've looked at 2 ways of finding it, and you do want to be familiar with both ways. The second thing you should be able to find is the Y-intercept. The third thing you should be able to find is the X intercept. Now all 3 of these are points, so they should be denoted as points. So remember, with the Y-intercept, often if you've got it written in standard form, the Y-intercept is going to be 0 and a C value. For the X intercepts, you're going to have some X value, call that X sub 1, with a Y coordinate of 0, and usually there's also a second X value that is another X-intercept. So most often you're going to find 2 points there. But also keep in mind, we looked at one example where there were no X-intercepts, so that can happen as well. Now there's a couple other things you should be able to do as well. The fourth thing you should be able to find is the axis of symmetry. And remember that the axis of symmetry is a line. So it's always going to be written as x equals, because again, as a line, it also is a vertical line. So x is equal to, and it's the same value as the x coordinate of the vertex, because this line always does go through the vertex. So this little formula that we talked about with the vertex a few minutes ago also works to find the axis of symmetry. And finally, you should be able to sketch the graph of any quadratic function that I give you. So that summarizes the information in section 8.6. You'll have your assignments posted, so good luck with those.